So this is just a quick overview of renal function, which should be pretty much just review from previous courses. So just a quick anatomy review. Remember that in the urinary system, urine is produced by the kidneys. It's going to be transported via the ureters to the bladder, where it is stored until we void, at which point it passes out of our bodies via the urethra. On that right-hand side is a close-up look of the kidney. So fluid comes into the kidney via the renal artery, where it's filtered before either being returned to the body via the renal vein or transported down to the bladder via the ureter. The kidney plays a lot of roles in the body and is vital for acid-base balance, electrolyte balance, and fluid regulation. Kidneys also filter toxins from our bloodstream. They assist in blood pressure control. They make erythropoietin, and they metabolize vitamin D. So, as a reminder, erythropoietin, this is a hormone that's secreted by the kidneys that increases the rate of production of red blood cells in response to falling levels of oxygen in the tissues. So we're going to watch just a quick little video about how the kidneys work. Some of the animations are a little bit silly, but the information is good, so just stick with me.
Cellular waste byproducts are soluble, that is, dissolve in water. And when they are eliminated, a certain amount of water is also eliminated. Our kidneys work as a filter to preserve as much of our body's water volume as possible. If they didn't, or couldn't, we would die of severe dehydration. Healthy kidneys filter all the blood in our body every 30 minutes. They filter and remove approximately 1.5 liters of urine every 24 hours. This would fill about 2.5 bathtubs in a year's time. Previously mentioned, urine production begins in the nephrons. A nephron consists of a bulb called Bowman's capsule, filled with a cluster of capillaries called the glomerulus, and a long twisting tube called the renal tubule. Blood flows from the renal artery into the glomerulus. Here, blood pressure forces much of the blood plasma, the fluid portion of the blood, through the cell walls and into Bowman's capsule. This is called absorption and is the first of 3 steps involved in the process of filtration, or filtering of the blood. If the filtering surface in every nephron in just one of our kidneys were smoothed out and stitched together, it would equal approximately 6 square meters, the size of a sail on an 18-foot sailboat. One kidney can absorb 125 milliliters of fluid per minute, or 20% of all the fluid delivered via the renal arteries. This fluid is called filtrate, and in one day, the glomeruli produce about 180 liters of it. This is 70 times the total blood plasma volume in our bodies. If the nephron only absorbed fluid, our body would soon be in trouble. We would obviously lose far too much water and other materials that the body needs. This is what occurs in a disease called diabetes insipidus, which can cause death by dehydration. During the next step of filtration, called reabsorption, the filtrate passes from Bowman's capsule into the renal tubule. Here, 99% of the filtrate is reabsorbed back into the capillaries surrounding the tubule and returned to the bloodstream. Driven by complex chemical and hormonal processes, reabsorption allows needed water and nutritional substances to be maintained at a useful level in the bloodstream, while removing waste, excess water, and other substances. In the final step, called secretion, any solutes remaining in the capillaries that were not filtered out originally are secreted into what is left of the filtrate.
Okay, and then just one more quick video just to give us a little overview of what our kidneys do. I feel like our kidneys are kind of underappreciated by a lot of people, and they are literally like one of our most important organs. So I just want you to have a good idea of everything they're responsible for.
It's a hot day, and you've just downed several glasses of water, one after the other. Behind the sudden urge that follows are two bean-shaped organs that work as fine-tuned internal sensors. They balance the amount of fluid in your body, detect waste in your blood, and know when to release the vitamins, minerals, and hormones you need to stay alive. Say hello to your kidneys. The main role of these organs is to dispose of waste products and to turn them into urine. The body's 8 liters of blood pass through the kidneys between 20 and 25 times each day, meaning that together, these organs filter about 180 liters every 24 hours. The ingredients in your blood are constantly changing as you ingest food and drink, which explains why the kidneys need to be on permanent duty. Blood enters each kidney through arteries that branch and branch until they form tiny vessels that entwine with special internal modules called nephrons. In each kidney, 1 million of these nephrons form a powerful array of filters and sensors that carefully sift through the blood. This is where we see just how refined and accurate this internal sensing system is. To filter the blood, each nephron uses 2 powerful pieces of equipment, a blob-like structure called a glomerulus, and a long stringy straw-like tubule. The glomerulus works like a sieve, allowing only certain ingredients, such as vitamins and minerals, to pass into the tubule. Then, this vessel's job is to detect whether any of those ingredients are needed in the body. If so, they're reabsorbed in amounts that the body needs so they can circulate in the blood again. But the blood doesn't only carry useful ingredients. It contains waste products too, and the nephrons have to figure out what to do with them. The tubules sense compounds the body doesn't need, like urea, left over from the breakdown of proteins, and redirects them as urine, out of the kidneys and through 2 long sewers called ureters. These tubes empty their contents into the bladder to be discharged, ridding your body of that waste once and for all. There's water in that urine too. If the kidney detects too much of it in your blood, for instance, when you've chugged several glasses at once, it sends the extra liquid to the bladder to be removed. On the other hand, low water levels in the blood prompt the kidney to release some back into the bloodstream, meaning that less water makes it into the urine. This is why urine appears yellower when you're less hydrated. By controlling water, your kidneys stabilize the body's fluid levels. But this fine balancing act isn't the kidney's only skill. These organs have the power to activate vitamin D to secrete a hormone called renin that raises blood pressure, and another hormone called erythropoietin, which increases red blood cell production. Without the kidneys, our bodily fluids would spiral out of control. Every time we ate, our blood would receive another load of unsifted ingredients. Soon, the buildup of waste would overload our systems and we'd expire. So each kidney not only keeps things running smoothly, it also keeps us alive. Lucky then that we have 2 of these magical beans.